Let's wait for people to trickle in.
Yeah, it's this constant, the way they let people enter, it's like one at a time.
Right, yeah.
If you're standing in line. Yeah.
All right. Let's give people one more minute. All right, okay. So let's go ahead and get started. So it's my great pleasure today to be hosting Professor Rayid Ghani from CMU. So Professor Ghani is a professor in the Department of Machine Learning and the Heinz College of Information Systems and Public Policy at Carnegie Mellon University. His research is actually very aligned with our own at CAIS. He develops machine learning, AI, and data science methods for solving high impact social good and public policy problems, taking a fairness and equity lens. He has looked at applications spanning from criminal justice to education, economic development, and public safety, among others. In his research, he collaborates with government agencies and NGOs. He also runs a very famous Data Science for Social Good Summer Fellows program at CMU, which basically trains aspiring data scientists to work on projects with social impact. So please join me in welcoming Professor Ghani and Rayid. Please take it away.
Thank you, and thanks for having me here. It's virtual, but please feel free to ask questions throughout. I know it's harder to do that over Zoom, but I'm happy to kind of take it in a direction that people are interested in. And again, a lot of you also do the same type of work that I do. So feel free to kind of take things deeper in a direction that you want to take. But I thought what I could do is sort of start off by talking a little bit about projects that we've been doing over the last few years, and then go a little bit deeper into how do we focus those projects on fairness and equity. And yeah, so I'll just start by giving some examples. Some of them are older, some of them are newer, some of them are updates on older projects. Let me share my screen and we can go. Okay. Can you guys see my?
Yes, we can see.
Screen? Perfect. Okay. Let's see. And sorry. Okay, perfect. Yeah, so I'll start by a project that we actually started several years ago, and that is criminal justice and working with a county in Kansas called Johnson County on reducing the rate of jail recidivism. And this is not a unique problem to Kansas. It's unfortunately a larger problem in the country. Criminal justice system is broken, and so these numbers that you're seeing here are just for jails. And yes, a lot of people move through jails, and yes, it costs a lot of money, but the really horrible parts are that most of the people going through the jail system in the US suffer from mental health issues, substance abuse issues, and they keep cycling through the system, which most of us have seen this happen. This county came to us a few years ago and said, look, we know we have a high rate of recidivism. We know a lot of these people have mental health needs that are not being met. We have some additional resources that we can use to provide them mental health services. we don't know who to allocate this towards that can help us maximize sort of the reduction in recidivism. So that's kind of the question they came to us with. And we worked with them to first, connect all the different data sources together, criminal justice data, sort of jail, prison, police, mental health data, other medical data, housing information, kind of everything else about them, to first put it all together. And then the first step was really, can we narrow things down? Can we identify the individuals who are going to be at risk of recidivism? And so the difference in machine learning to predict who's going to be coming back to jail. And then we sort of looked at their history to see which of them have mental health needs, so that we can kind of put the two together. At that point, we were able to sort of see, look, yes, we can accurately identify who's coming back to jail, but that's not the point. Now we can watch them come back to jail and be completely useless to them. So the next question was, does the intervention that they have, which is the hypothesis was that these preventative mental health services, these proactive services, can help them reduce their risk of coming back to jail. So now the question was, does that actually happen? So about 2.5 years ago, we started a randomized control trial, which was we would generate the risk score for each individual who's been released from jail in the past couple of years, and identify their risk of going back to jail. And then for those people, we generated a list that would then be given to the mental health team, and they would go out and do interventions with about a couple of hundred people a month. And we were measuring a few different things, right? So the first thing we're measuring was, does this work? Does it reduce recidivism on average? And so far we're finding in early results, it's not finished yet, that yes. Second thing we're measuring is, what are the other, is it having impacts on, so far we're finding that their arrest rate is reduced, their jail booking rates are reduced, and their rate of consuming mental health services has increased. So all good things. The second thing we're testing is, yes, on average it works, but does it work more effectively for certain people? Does it work less effectively for certain people? And so far we're finding that the people who are highest risk of going back to jail are the people who are being impacted the most, are reduced the most. And that's a little bit surprising, or quite a bit surprising to us, because the prior that we were going in with is the people who are highest risk are the people who are going to be hardest to change. And it's the people who are going to be kind of medium or low risk that I think will be easier to change, but we're finding actually that's actually not the case, and we don't really know why yet. But one of the things we're working on is then to sort of go deeper into that and understand that, so that we can then design interventions for the people who are not benefiting from this one. So that trial is now ongoing, and hopefully we're going to find some more results to go deeper. So let's get through. So that's one example. There's some of the older projects that we've done that have a similar flavor. This is a project we did a few years back in Chicago, which was around lead poisoning, identifying kids who are at risk of lead poisoning early before they actually get lead poisoning, because the current practice really is, in most cities, they test kids for lead. If they find high levels of lead, they then go and remove those sources from their house. But that's pointless, mostly because once you're exposed to lead, there's nothing you can do to fix it. So the only way to help the kids is to prevent that from happening. And so the idea here was, if we can identify early and predict when a kid is month, 2 months, 3 months old, that gives the health department time to remove the lead hazard before the kid starts crawling and gets exposed to lead dust, which they typically pick up and put it in their mouth. And, so the project that was, can we again connect all the data together about the blood tests, about the kid, about the home condition, about other homes nearby, to predict who high risk, and then allocate resources to go and check for lead hazards in their home and then remediate so again, we put these things together, built ML systems to predict the risk, and then allocate those interventions. We ran a randomized control trial and found that it was actually finding lead hazards at a higher rate, and it was doing it proactively. So that system is now deployed and implemented, both in the health department, but also being used in hospital systems to then move this process even earlier. So instead of waiting till the child is born, running it when the pregnant woman is going for a checkup, so that the electronic health record system will raise an alert saying this kid that's going to be born will be high risk, so that they have even more time to come up with the interventions and to reduce the risk of the kid being exposed, because it's going to happen before they're born, ideally. Another example, another horrible, depressing example is police misconduct. And it's all too common. It's everywhere. It's in Pittsburgh. It's in Chicago. It's in LA. It's everywhere. And so the challenge with the police misconduct, one challenge is that a lot of police departments used to think that they have these systems. Most large police departments, including LA, have these systems called early intervention systems that basically they raise an alert when a police officer is likely to be involved in one of these incidents. Most large police departments have them. They've installed them, paid for them, but nobody bothered to evaluate and see whether they did anything, whether they worked. And so we started doing this work a few years ago and started working with a few different police departments to see, can we help them build better systems? And before we did that, the first thing was, can we first evaluate and see if the existing ones work and where they fail, so we can see if we can improve them. And one of the things we found pretty quickly was that the existing systems were pretty useless. And so one example, in case if we were started working with in North Carolina, in Charlotte, found that their system basically flagged more than half the police officers in the department, which made it totally useless. Nobody trusted it. They just kind of ignored it. And the reason was that they were just built with very simple rules, like if somebody has 3 complaints against them in the last 6 months, raise a flag. If somebody has 3 uses of force in the last 3 months, raise a flag. If somebody's taken more than 2 weeks of sick leave, raise a flag, because they might be at risk of something horrible, and that made no sense. So we kind of took the same approach again, is looking at connecting all the different pieces of data together about police officers, their history, their training, the arrests they've made, the dispatches, the stops, the complaints against them, the investigations, the use of force, everything, and use that to say, okay, can we predict if you are at high risk of these events that we don't want you to do? And if we could accurately identify early, then the police department can work with the internal affairs team, with the counselors, with the employment, with the training people, to sort of see what are the interventions. In some cases, the intervention really is get you off the street. You shouldn't be interacting with people. You should be off. In other cases, the intervention might be training you for specific types of interaction. In other cases, it might be other types of interventions. So that system has been deployed in a couple of different departments and is being used, and we're kind of getting that data back to us to figure out how effective that is being as it's being used. There are kind of other examples of, again, these types of early warning systems that especially in work with a lot of different schools and education departments. So work in Arizona, in Maryland, in Ohio, in Oklahoma, in El Salvador, on identifying students who are at risk of, who may not at risk of sort of not let's say graduating high school, or students who need additional support in order to get to college or do well in college, or to get to reading grade in a certain, let's say 3rd grade, or different types of events that we don't want them to go through. And a lot of these things, compared to the systems, the human systems today, right? A lot of teachers know who the students are, but they might not know early enough in order to actually intervene effectively. And so a lot of this work has been, can we get to the schools want to know as early as possible when somebody may need additional support to let's say graduate on time. And the day before you're supposed to graduate, that's pretty easy to know. 10 years earlier might be too difficult. So what's the right sort of time in the middle where you're accurate enough so that the interventions make sense to do, but you're early enough that the interventions have time to impact. And that tension is going to be sort of in general, all of these types of early warning systems are, you want them to be early enough because these interventions don't just, you don't just press a button and magically a student graduates. You need time to change behavior, but you need to be late enough that you have enough information that you can accurately identify those students. There's another project we recently started that's kind of on hold right now, which is working with the government in Mexico to increase vaccination rates, not about COVID, but just regular, kids vaccinations, hepatitis, measles, all these horrible diseases. And a large number of kids there don't get vaccinated, not for the crazy reasons that people in the US don't get vaccinated, but more around access to the vaccine supply, how close they are to the hospital, things like that. So the idea was, can we identify kids who are at risk of not getting vaccines, and then using that to go and do outreach to their parents, or try to connect with them to try to persuade them to get their kids vaccinated in time. I know there's sort of some questions coming in, and feel free to do that. I'll actually, if they're meta questions, I'll wait. If they're kind of specific questions to what I'm talking about, I'll answer them as I'm going. And so in this case, the idea was, if we can connect those. So there are two pieces. There's the identification piece, which is who are the kids who are at risk, and the second piece is the piece of how do we change their behavior? How do we persuade the parents to get them vaccinated? And the third is sort of this resource allocation piece of how do we figure out who needs to connect to whom and what's the effectiveness. So that project is kind of right now on hold as we're working towards sort of figuring out running trials and working with them. So kind of stepping a little bit back from all of these, right? So there's sort of a few things all of these projects have in common. One is sort of this template of, there's a piece of understanding sort of who are the types of people who are at risk, what are they at risk for. There is a piece of machine learning and prediction, which is kind of narrowing things down of all the people we could intervene on, who are the people who are highest risk. And then there's a piece of sort of behavior change, right, which is how do we change their behavior? How do we get students to then graduate from high school on time? How do we get police officers to stop shooting people? How do we get the kids vaccinated? And then there is kind of this allocation of what's more effective over these, because in all of these cases, we're not, prediction of who's at risk is not the task. Changing their risk, reducing their risk is the task. But we often don't have data on that piece, right? We haven't tried changing the risk before. We don't have randomized data on when we intervened on these people. Here are the people whose risk reduced and whose risk did not reduce. And so we use kind of the initial risk prediction as a tool to then design experiments, to then do interventions in those people to get the data back so that we can the real model I want to build are I have 6 interventions. Which intervention will most reduce the risk of this person not graduating from high school? And so I want to sort of the probability of their risk going down conditioned on this intervention is what I want to do, but I can't train systems to do that. So I have to kind of do this multi-step process of risk models used to run experiments to then generate the risk, the model that tell me what's the best intervention. Now, by doing that, there's sort of these 3 questions come up, right? One is all of these questions are, none of these are autonomous systems. They are humans working, who are doing this work, and the machine learning part is sort of to help them do their job better. It's not to replace them. It's not going to be automated. And so then the reason that's important is that these systems have to be designed so that they help people, because you can have the most accurate system, but if they recommend something, if the person in the loop doesn't actually do anything with it, the accuracy is pointless. Right? So they have to be kind of designed to support what people are doing. Second piece is they're all unfortunately dealing with allocation of limited resources. And ideally, you wouldn't have limited resources to only remediate a certain number of homes for lead hazards. You should be able to remove all the lead hazards in the city. We're not there today. And so they can only remove so many lead hazards. The question is, how do we which homes do we prioritize? Or same for, every kid should have access to resources they need in order to graduate high school on time, or every kid should have access to vaccinations, but we don't live in a world where that's true. So this limited resource question of this many people need this help, they have this many resources, is a horrible and unfortunate reality. But what it leads to is a societal question around this third piece, which is, what is our goal when we're solving this problem? It's not a machine learning or AI question. It's really a societal question of, I have this many resources. Well, I can direct them all towards the people who are easiest to help. So I can help the most number of people. And I can be very efficient. And let's say, well, I have limited resources. How do I maximize the number of people that get helped by it? Well, then you're only going to focus on people who are cheapest or easiest to help. And that's going to lead to inequity. Or you can focus on people who you can change the most, focus on effectiveness. But again, that might not be the people who need the help the most. And so on the policy side, these questions come up around, well, how do we figure out what our goal is in this case? It's a policy goal. Is the goal equity? Is the goal efficiency? Is the goal effectiveness? Who should decide what that goal is? Who should be involved in that conversation? Who has a say in this? But then on the operational machine learning side, those policy goals have to be then turned into code, because the system needs to be designed for one of these goals very explicitly, or a combination of them, but that has to be very explicit. And so this question of how do we balance that, what do we care about, comes up in each of these projects, where at least in our situation, when we work on these projects, we have these conversations up front with a variety of people, with all the different people involved. Yes, the people who are running the policy in the government agency and nonprofit are involved, and the people who are designing these systems involved, but the people who are using the system, the case workers in the middle, the health workers, the school, educators, yes, they're involved. But then the people who are being impacted, they are a key part of these projects in trying to help and trying to understand what are their needs, what are they, what does equity really mean? What is, how do we design these systems with equity in mind as the primary goal, rather than really focus on efficiency, which a lot of existing systems are being focused on, is how do we help the most number of people, not necessarily the people who are being left behind. So what I would sort of, the kind of key question that comes up in all of these projects is, like, how do we develop these types of systems that are collaborative, human AI collaborative systems that are helping make decisions that ideally lead to fair and equitable outcomes. And the key, and so one of the questions that just came up, right, is how do you incorporate the population's needs and wants? And I think, and part of this process is all of these projects are, they're not done in isolation, in a lab, right? They're done, the communities, we have lots of meetings, lots of conversations with the people who are being affected. If we're working with the police department, yes, we go and meet with, sit down with police officers and work with them, but we then also go into the community to understand how they perceive the police department, because the data doesn't accurately reflect everything that happens, and we all know that. But then having having a process for going into these communities and really working with them, right? Because the goal here, when we work with a school or a health department or a police department or a criminal justice agency, is not to help those agencies. The goal is to help the people who are being impacted. So they are kind of the primary consumer. One of the challenges often comes up is you can't necessarily just go and ask, how do we build the system? We have to sort of make sure that we have the right people who they trust in interacting with them. This can't, it's not a traditional focus group. So it's not, we don't have a perfect way of doing it, but we try to sort of, as much as possible, to make sure that we're incorporating the people being impacted into the process of designing these systems, but also in evaluating these systems and how it, and continuous monitoring. So one question that sort of we really focus on here is, the focus is really on outcomes, right? The focus is not necessarily on, because you can imagine a lot of the work that we end up doing in machine learning around fairness and equity is really focused much more on, how do I make my machine learning models fair? And at some level, it doesn't matter if your machine learning models are fair or not fair. What matters is it leading to equitable outcomes for people? And the reason that's sort of important is, we can have a lot of sources of inequity or unfairness when we're interacting with people through these types of machine learning systems, comes from a lot of different sources, right? So it's sort of the focus really for us is not on making the machine learning fair, but really the outcomes fair, which means understanding where are the sources of disparity, right? So the biggest source, unfortunately, really is the world. It's not the data, it's not the machine learning, it's not the people. It's really the world that happens to be, the world is systematically racist and sexist and biased, and it generates, people. Certain types of people don't get hired for certain types of jobs, not because they're not qualified, but because they don't, because that's just the way things are done. Or and that process results in data that, when used to train machine learning models, results in accurate but horribly unfair systems. And so a lot of the focus really is in trying to understand existing disparities in the world, such that we can then start working on detecting them, but also then trying to reverse them through these types of resource allocation systems. The second piece is, let's say, we can look at the world bias. The second thing is, the world generated information, but then we chose to use it in arbitrary ways. We, the usual errors of, sample bias and measurement bias, and that's kind of on us, and what choices we made in using certain types of data and in looking at different sources. But even things like, what, sort of label bias, right? I think, like, one example of that's like in the police department case, when we're building models to predict which police officers are likely to be involved in, a shooting, for example, an unjustified shooting. But where does that data come from? What is an unjustified shooting? Well, every time some use of force happens, it has to be reported to the police department. Now, who reports it? Usually it's the police officers. And so there's a lot of noise and bias in what types of shootings uses of force get reported. But then who decides what is unjustified? Well, the internal affairs department in every police department does an investigation, and they decide justified, unjustified. So in a horribly, corrupt department, maybe no use of force is ever unjustified. Everything is fine. In which case, this data, when given to machine learning systems, it will never find something unjustified. And so it's hard to sort of correct that post hoc. And the question becomes, how do we deal with that? What's the impact of that? And that's sort of real challenge, where a lot of these, our ML systems require, we can deal with a lot of different errors, but this type of error is very hard to deal with. And so we have to be conscious about how do we mitigate that risk when developing these types of systems. The next stage that comes in, once the data is our machine learning AI pipeline, right? And that's where a lot of things that we do in that pipeline introduce downstream errors. So that can range from something as simple, or I'd call it simple, but most of these projects involve connecting different data sources together about people. And so one of the first steps we take is record linkage or matching, or entity resolution, whatever, different names for the same thing. And in that one, we know that a lot of our algorithms are going to be inaccurate. So we will link two people together who are not the same sometimes, and sometimes we'll miss people who are the same. And those errors are not happening randomly. Like people who have long names with lots of consonants next to each other tend to get missed. And people who have common names, who live on Main Street, and they tend to link together when they're not the same people. Now that downstream leads to lots of different errors, right? So for example, think of if you're trying to make loan decisions or credit decisions, you might miss somebody has two different jobs and has income. And if you don't link those two records together without a unique identifier, if you make a mistake, you're going to not count their second job, and you might not give them a loan because you don't think they have enough history. Or if you have two people who are different people with similar names that you mislink together, one person might have bankruptcy, in which case you're going to think this person has the bankruptcy and incorrectly deny them. And the fact that those errors don't happen randomly means that you're going to disproportionately impact people of a certain type. Or even simple things like when we have missing information about people, sometimes we don't think very deeply and just impute with mean. And so if you have a problem where you've got 85% of the people are male and 15% are non-male, you're missing, let's say, something very simple like height about somebody and who's not male. If you do mean imputation without thinking about it very much, you're going to disproportionately make a lot of non-males look like males because your imputation can be dominated by the data, which is going to be male. So there's a lot of things we do as machine learning developers, designers, that each step in the process of linkage, of discretization, or generating features, or choosing models or metrics that all lead to sort of disparate, impact downstream. And we have to kind of think about very consciously about each step. What is the impact of a decision that I'm making? How could it disproportionately impact certain types of people? And how do I guard against that? Right? And so even when I've built these models and focused on kind of all the right things, once the models are built, now you have to take action on that. And so you can have a totally fair system up to that point, but your interventions and your actions can have disparate impact on people. So it's not about the model, it's about the interventions that are happening. So an example of that is in the lead poisoning example I was giving. When we built that system initially, we focused on kind of making sure that we were being fair and across different groups of people. And then we started sort of seeing that when we were getting data back through these trials, we were sort of seeing that certain types of people were basically we would make these predictions of who's high risk, and then the health department would make phone calls to make appointments for to get inspection, and started noticing they were only making those phone calls in English, which meant that people who couldn't speak English were not getting contacted, or they were getting contacted, they were just not making appointments. So there, the problem, and it was resulting in much worse outcomes for them. So the problem was not in the machine learning system. The problem was in the intervention, and that's why the outcome piece was the one that we cared about, right? It's not, we don't care where the problem is coming in from the data or the pipeline or the action. If it's impacting the people we're trying to help, it's sort of our job to fix it. So that's kind of the overall process that we typically use is we sort of look at what we sort of end up doing is we sort of start by thinking through like defining what does it mean to be equitable, right? Yes, it's a word that we use a lot, but what is the operational definition? And that's where all the different people in the process, you know, the policymakers, the people who are using the system, the people who are being affected by the system, collectively they all come together to help figure out what is the equity goal. And we're actually working on some things there to kind of working on designing some workshops where we can elicit that very explicitly through that process. So that's kind of the first step. Is like, what do we mean by fairness? What do we mean by equity? The second step becomes, okay, once we have that operational definition, how do we measure and detect bias in inequity? Third step is, how do we understand the root causes? Where is it coming from? Is it coming from something that we did in the machine learning piece, something we did in the data, something that's happening in the world that we need to deal with, or is it something on the intervention side? Once we've done that, we first sort of take the step of how much can we deal with it algorithmically? Which aspects of it can we deal with because it's our fault? We didn't use the right data, or we didn't use, you know, we did the wrong record linkage. How much can we deal with? But we know that we're not going to be able to fix this just with data and with algorithmic interventions. So then we look at how do we mitigate the impact through adjusting interventions. So for example, if we know that we are in the case of, you know, we can start doing phone calls in Spanish. In the case of the lead poison example, or if we know that the machine learning system is disproportionately missing people of a certain group, then we can start allocating additional interventions towards those people to compensate for the problems with the machine learning system. And then we sort of have this monitoring and evaluation loop that kind of goes back and says, yes, we built this to be fair, and we measured it in the beginning, but is it continuing to lead to fair and equitable outcomes? Because a lot of these projects that we're talking about are sort of their longer term outcomes there, and not, you know, instant outcomes. So that's kind of the overall process we end up using for these projects, where there are kind of three big components, right? One is, what are the values we want our AI system to have? What are the and who should be involved in that, and how do we include those people? Second is, how do we build our system to achieve those values? And then how do we make sure that it did what we wanted it to do? So at a high level, like, those are the kind of the simple pieces of what do we want this to do? How do we build it to do it? How do we make sure that it did what we wanted it to do? And so I'm going to sort of talk a little bit about a couple of those pieces, just to kind of give you some specific examples of some of the tools that we've been building to support these processes, right? So the first question really becomes that operationalizing the definition of the very narrow piece of it is, what do we mean by fairness in these type of things? And, you know, if you've kind of been following some of the work that's been happening over the last few years, people keep coming up with more and more definitions of and metrics for fairness. I mean, at a high level, we all know, right? Like, fairness is not a machine learning concept. It's as much as we and people have talked about this for hundreds of years around, you know, on this topic. So I don't think there's that much to add. The question really becomes for us, how do we design our systems to try to achieve those values? And in all of these things, right, like there are sort of these some simple questions around what do we mean? Again, none of these are computer science or machine learning questions. Do we allocate equal resources to people from different groups? Do we allocate them proportional to their need? Do we not miss people disproportionately? Do we not, you know, intervene on people who don't need an intervention disproportionately? All of these things sort of have specific, you know, metrics that people have developed, and those metrics are, you know, all sorts of these things. But the question, so one thing that becomes interesting is, as the machine learning community over the last few years has sort of focused on this area, you know, something we found is that some of these metrics are incompatible. So if you want this, you can't have this. Now, what's happened because of that is a lot of the organizations that we work with, governments, nonprofits, they've been reading that work or reading coverage of that work, and they're making a couple of different conclusions on it. One that we're seeing that they're saying is, oh, I read this paper and said that you have all these different metrics and you can't have all of them if you want fairness. So that means if I use machine learning, I can't be fair. So I'm not going to use machine learning. I'm going to do things the way I've been doing it before. Like, no. This is nothing to do with machine learning. This is just about human decision making. If you allocate resources towards this, you're going to be able to achieve this. So I think that's kind of one piece is what a lot of people in the policy world are getting sort of paralyzed by all these different ways of measuring fairness. What do I do? Do I just pick one? Do I get all of them? And so one of the things we've been developing over the last couple of years is sort of some simple guidelines around how do you pick which metrics matter to you more. And it's less about the analysis. It's much more about the intervention. So we have sort of this framework that that's work that we're doing right now, what we call the fairness tree. And I'll kind of go to a specific part of it instead of showing you the whole thing. And the idea there is that, if you're trying to do something, if you have an assistive intervention, right? So if you're trying to provide health services to people to either because they're at risk of some disease or it's the lead poisoning, you're trying to provide them remediation services because they are at risk of lead poisoning, or after school programs to kids who are at risk of not graduating school on time. Providing that inspection or lead inspection to somebody who doesn't have a false positive, it's not that bad. It doesn't hurt you in this case. A false negative is much worse, right? Because you missed helping somebody. So for interventions that are assistive, missing people disproportionately is much worse for them than providing them an intervention when they don't need it. And so in this case, we want to sort of equalize some notion of false negatives, which is sort of this side of this tree. Now, if you're doing things that are bad, which maybe you shouldn't be doing in the first place, but if you take sort of denying somebody bail, or that if you deny bail incorrectly, that hurts you much more, at least to the people who are being impacted. And so that's a punitive intervention, in which case you want to deal with equalizing false positives, because it's going to have much more disparate impact on people if you had disproportionate false positives. So the idea there is kind of thinking about what is your intervention, how is your intervention affecting people? What are the costs of false positives? What are the costs of false negatives to the people who are being impacted? And then prioritizing certain metrics as your fairness metrics, rather than sort of try to achieve all of them. Sometimes the answer is not that clear. Is it a punitive intervention? Is it an assistive intervention? So take like child welfare is a good example of that. It's not clear because it depends on whose perspective you're looking at. If you're building a system to sort of to take incoming calls that are coming in through a hotline and deciding should you start an investigation around a child and a family, well, if the intervention of taking a child out of a family, it's punitive to the family. If you're wrong, you've hurt this family because you've taken this child out. It's punitive. But at the same time, if you're wrong on the other side, it's punitive to the child because you're putting this child at risk. So whether it's a punitive intervention or an assistive intervention really depends on your value system and what are the ways you're mitigating the risk of being wrong on either side. So sometimes it's not obvious which metric you care about, but our sort of hope is that this gives people a starting point to have these conversations, as opposed to trying to get everything. It's like, what's more important? What are the different measures that you're using to deal with it? And what are the different risks of intervening? And then you don't need it, and missing people, and then coming up with some sort of a narrower prioritized set of things. So So that's kind of the first piece is on the definition side, is how do we help people figure out which metrics matter based on the values they care about and the interventions that they're doing. The second thing is, how do we then audit the systems for that type of bias or for that metric? So we have a tool that does very simple things. It's nothing complicated. And now the many other versions of that tool, different organizations have built different versions. IBM has one, Microsoft has one, other software vendors have started incorporating them. Initially, when we started building this tool 5 years ago, the idea was to provide this to governments, nonprofits who are sort of using these types of machine learning systems so that they can audit them for bias and fairness, and then make sure that they're not being used unless they've been audited. And what it does is pretty simple. It just takes the predictions of the model and asks the users, what metrics do you care about? What groups do you care about? And runs an audit and says, if it passes, if say you care about equal false negative rates for certain groups, it will audit the model's predictions for those and tell you whether they passed or failed. Yeah, so fairly straightforward. But the idea is to incorporate this into the process of designing machine learning systems. So you're kind of doing it at each step. It's just happening in each step, as opposed to if at the very end, because it's something that we have to kind of have constant feedback on, as opposed to build something and then check at the very end. Now, the check at the very end thing, we want organizations to do when they're buying these types of systems. If you're a government agency who's bought a system, you should audit it before you start using it. But if you're developing these systems, you should be sort of doing these audits continuously and really putting in the notion of sort of bias and fairness into the design at each step, right? So for example, like if you sort of think about the standard process for building machine learning models, you sort of have some performance metric. And even if it's a good performance metric that kind of captures the nuances of the domain, it's certainly not F1 or accuracy or AUC. Those don't incorporate anything about the real life constraints and the real life notions of performance. But if you even have the right type of metric, it's sort of a single dimensional thing. And so often when we find is that when we start thinking about, just even the notion of bias or fairness, we start sort of seeing a more nuanced view, which like you might have picked this yellow-orange model, but now it might be okay to pick this green one because it sort of gives you a view into a different dimension. And bias is not the only dimension, right? We might also care about how understandable, explainable this system is. How much do people trust it? How much does it help people? How stable is it? How much data does it use? If you care about sort of maximizing privacy at the same time as what's the cost of that? And so to kind of, I'll give you an example where sort of these types of trade-offs start showing up. So this is some work we were doing a few years ago with a hospital system who was trying to design a way to kind of decide which people to screen for diabetes. And the idea was that there are these screening guidelines for diabetes that are developed by this organization called US Preventative Services Task Force. So they have certain guidelines that are based on the body mass index and the age of individual. And what they say is, if you have this range of body mass index and this age range, then you should be screened for diabetes. And the problem is that was designed using data from white people. So it doesn't work very accurately, it kind of underdiagnoses non-white people. And so this hospital system said, we want to be able to do better. Can you help us design something that gives us early warning of who's at risk of diabetes so we can screen them today? And they wanted screenings to ideally be, they wanted a few years early warnings, 3 years, because they said that's how long it takes to change behavior in order to reduce somebody's risk of diabetes. So before we built the system, we first wanted to audit the existing process, the existing kind of what physicians do today. Who do they screen today? And so in this case, what you're seeing here in this case, it's an assistive intervention. So it's missing people disproportionately is much worse. And so we want to minimize we want to equalize, minimize and equalize false negatives, right? So this is the y-axis is the false emission rate. So the lower, the better. And so this is kind of auditing the existing human process and checking the false emission rates for different groups. In this case, we find that the existing system is pretty bad for 40 plus people, 40 to 70 and 70 plus in age. It's much worse for Native Hawaiians and Native Americans. And yeah, it's equally correct, equal rate for male and female. So then we designed the machine learning system and compared it. And so this graph, the orange line is the line from the existing human system. The blue lines are the lines from the best, the most accurate model. If you notice, there are two things here. One is in each of these groups, the blue line is lower than the orange line, which means that for each of this group, the machine learning system is doing better than the humans. And so it reduces the false emission rate. It's better for every single group, but it's introducing disparities. So for example, in this case, the human system was bad for both, but it was equally bad for both. The machine learning system is much worse for 70 plus people and not as bad for 40 to 70. So it helps both groups, but it helps one more than the other. And that could lead to downstream disparities. Same for here. It was equal for Hispanic and Black people, but now it's worse for Hispanic than for Black people. So it's better, but more disparate. And again, that's a value question that we have to figure out, is what is the impact of that and how do we deal with that? And is that what's better? This one is fair, but unjust. This one is not fair, but better. So then we sort of designed a few different versions of it, just to kind of give you a flavor for. Here was a version that said, well, if we really wanted to focus on a specific group and say we wanted to reduce the false emission rate for Hispanic, let's tune the system to do that. Well, when it does that, it increases it for Black people, and it increases it for 40 to 70-year-old and reduces it for 70 plus and increases it for white. So there are kind of these, tensions going on here. Then we said, okay, what if we designed it to be equally right for across all different racial groups? So this mustard colored line, but that's the same thing. In order to sort of decrease for one group, it had to increase for a different group. And so we kind of decided to take a different approach for this problem. And so I'll sort of just describe that approach in a different project. And so this project is kind of similar to
Rayid, I'm sorry to interrupt. I just want to say that we have about 5 minutes left. So it depends how you want to use it, if you want to use it for questions or to continue.
Okay. Give me two minutes, and then I'm happy to stay later as well if people have questions as well. So actually the 1 minute a different approach was we sort of took that problem and kind of turned it into a policy menu. Said, okay, if you want to make the most accurate system, it's going to be the most efficient, where most of your resources go towards people who need it. If you have disparate performance for each group, one group's, they both go down in, this is the recidivism rate. So both groups go down recidivism rate, but the white rate was lower than Hispanic. So if they both go down, but one goes down faster, the disparities go up. So we designed sort of option number 2, which is equal performance for every group. That reduces the disparity, that reduces the recidivism rate for both. It doesn't increase disparities, but it also doesn't decrease disparities. So then we designed option number 3. And that was performance that was proportional to their need. And now it reduces it for both, but it reduces the Hispanic recidivism rate at a faster rate so that you get to equity in recidivism rate downstream. And it turns out they're all about the same cost. So it doesn't cost. And so in this case, giving them a menu to say, well, you can have, total efficiency and increase disparities, or you can, slightly more expensive and equal recidivism rate. What do you care about from a policy point of view? And they chose number 3 in this case, But that kind of in the back, there was a lot of, math and algorithms and all these things. But the front part was really, here are the policy menus. And so that's kind of an example of sort of how to navigate some of these things on both on the policy side and then on the algorithmic side. And the last thing I'd say is we're actually finding that in a lot of these projects, we're able to there is no trade-off between sort of accuracy and fairness. We're actually able to get both. But we don't get those if we just build a system. We have to explicitly design this system. And I'm not gonna talk about the details of that. I'm happy to talk about it later or point you to papers. Is if we just take some of these algorithms and use them off the shelf, we don't get fairness. But if we sort of design the system the right way, we end up not trading off any accuracy and end up getting fairness as well. So those are some interesting results that we found recently that we're excited about, and we're kind of going deeper into understanding it. And that's basically all I had. Let's skip through all these things. So, but yeah, so the summary really was a lot of the times ML is being used even in sort of social impact space to sort of be more efficient. I think we kind of need to focus a lot more on fairness and equity pieces of it as primary goals and metrics in these systems. And I think these types of collaborations that we're doing and a lot of you are doing are really the right way to develop these types of things to have a real impact. So I know I went much longer. So happy to take quick questions. I know there were a couple in the Q&A. Also happy to stay longer and or chat afterwards as well.
Thank you so much, Rayid. Thank you. Let's thank our speaker, everyone. So I want to open it up for questions. We have a couple in the Q&A. Maybe we can start one from there and then take one from our panelists here. So the first question is asking, do you feel that your positive impact is maximized as an academic studying AI for social good? And in general, what kind of impact are researchers able to have in industry versus in university?
That's a good, I mean, that's a really good question, right? And it's unfortunately not a 30-second answer question. It's a question that I think all of us ask ourselves every day, if not more often, is where is your impact maximized? Should you be in a university? Should you be at a nonprofit? Should you be in a government agency? Should it be in a foundation funding this type of work? Should you be on the ground, kind of working with people hands-on? And I think for each, there is sort of what is the impact, but then there's also for you individually, what are your skills? What are you good at doing? I think all of us, I think has to be a portfolio. I think each person has to sort of, and you don't have to be in one place forever. It's not like universities only or not. I think you have, the real stuff really happens inside the organization. You can only do so much from the outside. But in the inside, you have a lot of day-to-day things that you're worried about, that you're dealing with, that you can't always focus on some of the other things. So I think you want both. You want people who are on the ground doing the work on the inside, but you also want to support them from the outside and try to sort of, so I think I'm happy to talk afterwards. It's just a more nuanced. So I think it's all of the above is the answer. And I think for each individual, you have to kind of figure out at this moment in time, where are my skills most useful and what impact do I want to have in the very near term, and then update that calculation every year, every couple of years.
Thanks, Rayid. Let me ask Eric. I think, Eric, you're raising your hand, right?
Yeah, Rayid, thank you so much for such a great talk. I wanted to just kind of, I don't know, I think Phoebe will be shy to put herself out there in the way that I think maybe I want her to, but it's the I think Phoebe's been doing some really interesting work that I think is really complements what you've been doing really nicely. And we've been thinking about I was struck by when you were talking about the balance between fairness and sort of efficiency or accuracy of these systems. And one of the things that she's been leading an effort on is because we're engaging with community stakeholders and trying to get them to help us design systems wherein they, help us think through fairness and efficiency and transparency. And, she's even worked on some algorithmic ideas about how to even present such complicated trade-offs in a more sensible way. And I'm kind of wondering, sort of what has been your thoughts or experiences with, how to, because clearly you've got lots of implementations where you've done this with real communities, right? So how, what has been some of your insights about how to effectively start to engage those stakeholders in these very complicated conversations that ultimately should be their decisions, not ours as researchers, right?
Right. Yeah, no, and I've seen some of that work, and it's exactly the type of work we know we need more of. I think the parts, like, we're so far from, I think, having those conversations right now. We don't. I think one challenge that comes when people go out and try to have those conversations with the stakeholders who are being affected. The stakeholders don't, the community members don't have enough information to really be useful co-designers, useful participants. So, for example, one of the things we're doing right now is creating sort of, for lack of a better term, some sort of guides for communities to help them better understand how some of these systems that are affecting them, how are they built, just background primers, and not in papers but like right now we're talking about doing sort of podcasts that we can get out to the community and do it through people kind of having interviews with people and kind of having conversations, recording them. I don't think we have great ideas, to be honest. We're trying to figure out what are most effective ways for this. Because, again, Phoebe, some of the work you're doing around sort of incorporating transparency into this, right? Like it's not even transparency, because we can get transparency by just printing out these models. That's not useful. It's transparency. But I think our experience has been, we don't have a kind of a standard way, right? We sort of do it differently with each organization we work with around each issue. And I think, and maybe that's the way to do it. It's just, it doesn't feel like we learn from each time. So I don't have a great answer on, a solution, but I think it's a problem that we, all of us, are kind of struggling with when we're working on these projects that we need to kind of figure out.
Thanks for sharing the vulnerable and honest answer that it's difficult, right? I think sometimes people assume that, if you've been able to do this kind of work effectively, that it means that you've got some sort of silver bullet for how to make it work. And so thanks for that very honest answer.
No, I don't. I wish, I hope other people have, because it would be great to do that. Yeah, no, I think I would say, like, even the very high level, do universities know how to work with communities around them in any way yet? I don't think so. I don't think I haven't seen a. I really want that to be true, but I think we all struggle with that piece and need to do more of it.
Thanks, Rayid. I actually had a follow-up question along those lines, about the fairness tree idea. So that seems super useful. And, I would agree with most of the recommendations. I'm wondering, in your experience using it, though, with the community, has there been some backlash that, oh, you are telling us what the fairness notion should be instead of the opposite, right? It may seem that now they don't have the option somehow.
Right. So so we started the fairness tree as really for ourselves as a tool, not for other people, for the community. And over time, we sort of realized that it gave us a framework to think about for ourselves. So it's not, I wouldn't take this tree to a person who's being investigated by, child welfare agency and say, what metrics should I use? Like, this is not, I'm actually working with a student right now on turning this tree into kind of like a workshop tool, where we wouldn't show the tree, would sort of ask questions about what, and it would what I sort of find useful is that it helps you figure out where disagreements come from. Because right now, if you don't disagree you don't agree on the metric, you sort of don't know where to go next. Here, you can say, you agree that this intervention is this, but you disagree that so it's kind of more trying to have a structured conversation and then finding points of disagreement. And you might sort of get to a point where you still don't agree, but at least now we have it. So this is not designed to be a tree that you give an individual and say, tell me where you are here. It's really saying, if these are your values, your machine learning system should prioritize these metrics. Like so it's really the link between values and through the interventions, because other pieces, like people get stuck on the analysis part. And so I sort of keep, if we're the project I talk about on the criminal justice side, we're predicting who's going to go to jail, which is basically predicting crime. And what does fairness mean in predicting crime? Like, I don't reported crime, right? Well, I don't know what that means, but I know that if the intervention is providing mental health services, I don't want to miss people disproportionately. But if you're going to do something much more horrible, which you shouldn't in the first place, you shouldn't be maximizing equalizing false negatives in that case, if you care about fairness. And so I think it's really kind of saying that. So that was the reason for kind of thinking it that way, is one, it's the interventions that are much more important. And then two, getting to it in a little bit more structured way helps us mediate some of the disagreements, and also have different stakeholders reach different. So one of the things we're trying to do right now is for a given area problem, if we work through these workshops with different stakeholders, they might get to different metrics, but it's not because they care about different metrics, it's about their values are different. And so even getting to the point of saying, okay, the parents care about this, the kids care about this, the social workers, the caseworker care about this, the agency heads care about this. And so what do we do now? How do we mediate? So again, like, this is less a definitive answer. It's really more of a discussion tool that's a little bit more structured than give me the metric. And it's really in response to a lot of the people we're working with. We're sort of saying, well, we read these papers on fairness and they have these 20 metrics. What do we do? Like, no, don't worry about, like, that's, yes, they exist. Don't reason in the metric terms, reason in the values and the intervention, and then we'll help you map those to the other piece.
That makes sense, yeah. Let's take another question from the audience. How would you respond to someone concerned with the privacy of the people whose data are being fed into governmental ML modules?
That's a good question, and I'm glad that's an important. I think in this case, in every single project that I talked about, the data is being used by the agency that's collecting it, and so there isn't really additional privacy risk. It's the idea is that it's not being made public. This is all about individual sensitive data that's staying there, and today that data is being used to contact them anyway. And so the change that's happening here is saying, and again, this is exactly what, Eric, you were asking about, is the people affected by it should have a say in, do you want to get additional services to help you proactively? Or would you rather not get that? And kind of, it's less, again, transparency. It's much more nuanced than that, because like, what's the value of this additional service? Is it helping me? Is it hurting me? What is the privacy risk? But at a high level, in all these cases, this is not work done kind of independently. It's work done with these organizations who already are collecting this data and are using it to do outreach. It's just not outreach necessarily to the right people. So it's reallocating the resources, but not using additional data that wasn't collected before, or making it available to anyone that wasn't available before. Yeah, so it's a little bit more nuanced than that, but I think it's something, again, that we have to be able to communicate to the people whose data it is and kind of have it be their say, if hopefully they're informed enough to kind of make the right, call. And if they don't want this to be used, then that's sort of it's a choice that people should be able to make, but it has to be an informed. The challenge is it's difficult to give all the information to people in a way that they can make informed choices around these things. But it's the right question to ask.
Thank you, Rayid. So let's take one last one so you can join your meeting with Bistra afterwards. So the last one's asking, what is your opinion on using symbolic methods to solve such problems? Example, producing a synthesized rule to guide the decision making.
Yeah, that's a good point. And there is, Cynthia Rudin has been doing a lot of work on kind of these rule-based or scorecard type systems. And the reason for that is that a lot of these rules, a lot of the existing systems in place are those kinds of point systems, these rules. And so we think that those are more accepted by people. I would argue, I'm not sure if they're any more interpretable, understandable. If you wanted to sort of have a scorecard with 6 different characteristics, and this one you get 3 points for this, 2 points for this, 4 points for this, and the sum adds up to more than 8 points, you are high risk. If you're otherwise, if you wanted to sort of tell somebody here are all the ways and you could be high risk, that's a pretty complex, like I can't do it in my head. And so I don't know if they're better. I think they seem better. I don't know if they're easier to interpret or understand, but in my mind, I sort of separate out the modeling from the implementation. And so the implementation might need to happen on paper, which means that I might need to simplify. And so my analysis could be complicated, but then I might need to cut something and lose some dimension of it in order to implement it. Because it needs to be static for at least a month. It needs to be printed out in paper and posted somewhere. And it has to be, up to 3 rules. Like it has to be made within 30 seconds. I think, but I would kind of, again, think of it as providing a policy menu. It's like, here is, one side of it where you can sort of do this, and here are the value you get. And then if the middle might be some sort of, a symbolic rule-based thing that we've learned to rule that is easier to understand, maybe misses certain people who are high risk, but gets acted on much more often. So it's more effective because more people use it, to the existing system today that is totally human-based, that doesn't work very well, but gets used a lot. And then you sort of provide this menu and try to figure out what's the right thing to do. I don't know if I would blanket go to always to the rule-based thing, or blanket go to the machine learning thing, or blanket go to the existing human. I think, I feel like all the answers I'm giving are, because these are all sort of really good questions with, in my mind, not clear yes, no answers. It's so contextual, and that I have to kind of do that, not a clean answer.
That makes a lot of sense, Rayid. Thank you so much for sharing your experiences. I do want to make sure you have time to meet with Bistra. So let's thank our speaker, everyone. Rayid, thank you so much for joining us. I really appreciate it. Yeah, enjoy the rest of your virtual visit and see you again soon.
Sounds
Thanks
good.
so much.
Thanks. Good seeing you guys.
Everyone for joining. Bye.